The last application that we want to look at is the marginal productivity of money. So before we get into what that is, let's work another example here, or more accurately what we'll do is give the results from another example, but it would be worked very similarly to example 6. So we have another Cobb-Douglas production function. If $600,000 is budgeted for production of the product, we want to determine how that amount should be allocated to maximize production. So again, similarly, we'll spend some amount on labor, some amount on capital. So to solve this problem, we need to optimize or maximize that Cobb-Douglas production function, subject to some constraint. So in this case, we have $600,000 that's budgeted. Units of labor cost $60, units of capital cost $120. So we would have the constraint of 60x plus 120y equals 600,000. So we go about setting up the problem the same as we did in example 6, and then in optimizing that function, we would find that production would be maximized when we use 8,000 units of labor and 1,000 units of capital. In that same step, the maximum production would also be output. So by utilizing the 8,000 units of labor and 1,000 units of capital, that maximum production would be 316,682 units. So again, you should repeat that example on your own. Make sure you can work through the steps to get those results. But we're going to skip ahead to talk about the marginal productivity of money. The marginal productivity of money gives us the approximate increase in production for each additional dollar that we spend on production. So essentially, we can approximate what's going to happen to our production level if we increase our budget. So to find that marginal increase the marginal productivity of money, we multiply the opposite of whatever our value for lambda is. Keep in mind, lambda was a value that came into play when we did optimization with constraints. So in manually working that problem, there would be some value for lambda that we would find. So we multiply that by our change in production budget. To find the approximate increase in production. So if we know our value for lambda, which means we know the opposite of lambda, and we know the increase in our production budget, we can come up with an approximate increase in our production levels. So in this example we were just looking at, if we know that our value for lambda is negative 0.5278, we want to find the marginal productivity of money and estimate the increase in production if an additional $50,000 is budgeted for production. So the marginal productivity of money is the opposite of our value for lambda. Here lambda was a negative 0.5278, so the opposite of that will be positive 0.5278. So that's our marginal productivity of money. The increase in production can be calculated as the opposite of lambda, so that 0.5278 times the 50,000, the additional money we're going to budget for production, which leads us to approximately 26,390 units. So using that value for marginal productivity of money, multiplying it by the additional amount that we plan to budget for production, should increase approximately our production by a little over 26,000 units.